let me explain it here. AOB. Okay, we first draw an arc here. So this is C, the intersection with this. This is D. Then OC, this, and OD are equal because it was an arc. I explained that before. A piece of a circle. In a circle, the distances from the center are equal. And then we describe another arcs from here and here, and the radius of this arc was equal to the radius of this arc from C. Okay, then and let's call the intersection H, and CH equals to BH. And then we said OH is the bisector. Okay, which means that this angle equals to this. Okay, but why? Because the two triangles here are congruent because of the second rule. Because this side equals to this side, this equals to this, and this side OH is common between two triangles, then according to the rule number 2, these are congruent, so the corresponding seams are equal, and the angle corresponding to this CH is equal to the angle corresponding to DH, which is equal to this, and that angle is this. Okay, so OH divided the original angle into two equal parts. Okay, and and one thing in which we need to bisect an angle is in drawing or in inscribing a circle inside of a triangle, and in decorative designs, which means that you draw a circle inside of a triangle which touches the three sides, and the center of it is the intersection of the bisectors of these two angles, or these two. I talk about the reason later. Inscribing a circle inside of it makes it cube. Okay, let's have another example, and this is drawing we got a line, let's call it D, and a point A, and we want to draw a line which be perpendicular to this, which means that we want to draw AH in which this be a right angle. Okay, but it is useful, for instance, the distance between a point and a line is defined to be the length of AH. Okay, so how could we draw it? Again, using the compass. So I first explain the method, then the reason, so we first draw an arc with the center at A, now long enough to intersect the line D in 2 points. Okay, and let's call it B, the intersections B and C. And from B and C, draw another arc, now with the center of B and C. Another arc, be it with any radius you like, but the radiuses should be equal. So let's say the arc of this with the center of C, and this arc with the center at B, and they intersect here. Then join these two, and this would be the AH could be perpendicular to line D. And why this is the case? Let me here A, and this is B. First is that by drawing an arc, AB and AC are equal because are the radius of this arc, which this arc is a part of a circle. So AB equals to AC, and later we draw another arc with the same radiuses at B and C, and they intersect here, which means that let's call it F. BF equals to CF because the radiuses of the arcs were equal. So this is F, and these two are equal, and let's join F and A. Now here we got two triangles, the right side, this and this, which three sides are equal. This from this triangle equals to this side from the right triangle equals to this, and AF is the common side of both. Then the two triangles are congruent, so the other parts of them are equal, which means the sides already are equal, which means the angles are equal. But we not done yet, because that doesn't tell us that this is 90 degrees yet. Okay, so but But so far we know that this angle equals to this angle, okay, because they are correspond to this and this. Now, in this triangle, now, in these two triangles, this side equals to this side is common between them, and the angles included are equal. Then these two are congruent also, and the corresponding parts should be equal. And the corresponding angle to this side is this, and corresponding angle to this side is this. Okay, they are equal, and also the sum of them is 180 degrees, because this is a straight line. Then each of them should be 90 degrees. Okay, and which means that AH is perpendicular to D. And drawing a line perpendicular to another line from a point outside of that line, is used in another cases in measuring lands or surveying. But this is the thing that I talked about, that the distance from the point is the length of the perpendicular. It's just one application of that. And here's the last rule for congruent triangles, which is if in two triangles two angles be equal, also the included sides, then they are congruent, and let's make use of that.